Hello and welcome. Welcome to my YouTube channel PHARMAVEN. In today's video, I will be discussing about biological indicator failure in steam sterilizer qualification or autoclave qualification. So, during initial qualification or maybe during the requalification of autoclave, we may encounter biological indicator failure where one or more biological indicator inside your load pattern may fail. So, how we can investigate? Let us understand. So, I will be covering 5 important aspects of BI failure investigation. First will be load arrangement, second will be cycle parameters, third will be placement of biological indicator, fourth will be quality of biological indicator, and fifth will be steam quality. So, on these 5 topics I will be discussing today about biological indicator failure in autoclave. So, let us first start with load arrangement. So, in case the load is new or we are going for the requalification, just check that how we have arranged the load and why load arrangement is important. So, in order to steam to freely flow inside the chamber, freely flow between the load items, we need to place load in such a way that it allows proper steam distribution inside the chamber between the loads. It allows proper steam penetration. So, if just check your load, for example, you have garment load or load with the rubber stopper bag. So, if you place garment one over other without having any space in between for steam penetration, or if you stack the rubber stopper bags one over other, then there will be very little space or absolutely no space for the steam penetration between the bags. Same goes for the filling machine load. If the silicone tubing, if the load has silicone tubings and it is coiled in such a way that it will not allow any proper steam penetration. If I have jumbled or to keep together all small items in a bunch, then there is a possibility that steam may not penetrate inside the load. So, check for the load items. Another aspect of load item is in most of the autoclave there are multiple shelves with perforation. First check it out if the shelves are perforated or not. We must need perforated shelf because there is lot of condensate being generated while the steam sterilization cycle goes on, and that condensate has to be drained towards the drain. So, if we are not provided perforation or not enough perforation, then that water may clog and it will lead to not achieving sterilization temperature in all the areas of chamber, all the parts of load, and can lead to biological indicator failure. So, just check it out, the shelves are perforated, and if the perforations are there but not enough to allow the water to flow, water to drain, condensate to drain, then we have to relook how we relook it at it, and we may want to increase the number of perforation or size of the perforation. Second thing, if you are stacking the load or you are keeping the load item very close to each other, or we are keeping the large load items on first shelf, and if my steam is coming from the top, if my steam distribution is from the top, steam inlet is from top or steam inlet is from the sides, but if we are keeping the bigger load items on the upper shelf, then it will generate lot of condensate which will ultimately fall onto the lower items. So, if that stacking is not proper, if the arrangement on the chamber shelf is not proper, then what will happen? The condensate from the first shelf will go to second shelf and then to third shelf. So, third shelf has a very high amount of condensate. So, if the load is not properly arranged shelf wise to allow enough water drain, enough condensate drain, then there are chances that the lowest shelf load items may not achieve the enough quantity of steam, enough steam penetration, and then it may not achieve the biological indicator 6 log reduction which we have claimed. Coming to the load items again, if you have very big load items like rubber stopper bowl or seal bowl, and if it is not properly arranged, if it is at a very high chances of getting the condensate accumulated, and if our cycle is generating lot of condensate and if it is not properly arranged, maybe it has to be kept upside down, maybe it has to be kept inverted, maybe we need some tiny perforation at the bottom so that it will allow the water to flow out of the bottom of the seal seal bowl or rubber stopper bowl. So if these big load items are there inside the autoclave, then it may generate lot of condensate, may retain lot of condensate, which eventually may not help in achieving the desired sterilization temperature in that specific load item. So this is how the load arrangement plays very key role in your sterilization cycle. So just check your load when you get the BI failure and the specific location of BI whether that at that specific location the load arrangement is okay, proper or not, whether it is allowing enough steam penetration, whether there are chances of condensate accumulation. Just check these 4 or 5 important factors, and if you are finding that there is a difficulty with the load arrangement itself, that it may not achieve the sterilization temperature, then we may want to rearrange the load or think differently how we are going to place the load. We can use SS stands for keeping the garment, keeping the rubber stopper bag. We can use different accessories, we can hang some items if required inside the load, so that it will allow enough steam distribution and steam penetration. This explains how load arrangement can be a problem. Now second part is cycle parameters. So when you have a BI failure, first is load arrangement, then also check the cycle parameters, and cycle parameter checking means in-depth evaluation. For example, take your cycle, just see how the vacuum pulses went, how the steam pulses went, how the sterilization hold was there, were there any extension in vacuum pulse, where the extra time taken in achieving the same amount of vacuum, compare with the other good cycle, previous good cycle, and with this failure cycle, and see there whether there are any difference in time of vacuum, by what time vacuum has been achieved. For example, in your normal routine, the first vacuum pulse takes 5 minutes, and in this cycle it has taken 8 minutes. Then there is an indication that some problem will be there. Air might be coming from some external source, there might be a leak inside the chamber. Okay, we are doing the leak testing of the chamber, but while load arrangement, while placing the thermocouples, if there is leak left out, there is a minor leak, then it may lead to the air inlet and we may not achieve the vacuum within the time. So just check it out. Same goes with the steam pulse, how much time it usually takes for first heat up, second heat up, third heat up, whether the same pattern has been maintained. Just overlap the cycles with the good cycle and check it out that if the steam pulse has also followed the same pattern as per the good cycle. Then check with the sterilization hold time whether the entire hold time cycle has been done exactly. Are there any fluctuations in temperature? Are there any fluctuation into the pressure? We put number of thermocouples inside, check all the thermocouple data in terms of achieving the temperature, check the pattern. We have the acceptance criteria for minimum temperature, maximum temperature, difference between minimum and maximum, difference between average temperature and minimum temperature, difference between average temperature and maximum temperature. Just check all these parameters, whether all these parameters are meeting or not. If there is certain issue, for example, at specific location there is a BI failure and the temperature in that specific sensor has fluctuated, then we can say that, then we can correlate that because of this temperature fluctuation it may lead to not achieving the BI killing, appropriate BI destruction completely. So just check these parameters. Also check that entire cycle with maybe 5 previous good cycle, previous requalification. If it is a requalification cycle, then check with the previous requalification that whether it is meeting the same requalification criteria, whether the cycle is comparable. One more thing in terms of load arrangement which I missed, that whether check that there is a appropriate procedure defined, that how to exactly place the loads, whether we have clearly defined photographs or schematic diagrams which explain to operators that what exact location, how many exact number of items can be kept in the load pattern. So many times there are gaps into the system that a protocol defines load arrangement differently, SOP defines load arrangement differently, there is a mismatch, or there is absolutely no procedure defined, just a photograph is given which is not clear, or just a schematic diagram which is not clear. So to have a proper load arrangement, there are three important factors. First is clearly defined procedure. Second is clearly defined photographs, clear photographs. We may use multiple photographs, one from the loading side, one from the unloading side, separate photographs for each and every shelf. And schematic diagram, if required, we can have schematic diagrams also, which just a diagrammatic representation that which load item has to be kept at what place. So this helps very importantly that the operator will put the exact load item in exact the same location in exact same manner by referring to the procedure, photographs and schematic diagram. So this helps to prevent biological indicator failure in requalification, as well as to have appropriate sterilization during each load when you are going for the commercial productions. This is one more aspect of load management. Coming back to the cycle parameters, check each and every step, pressure, temperature, whether there is any temperature drop, temperature fluctuation, pressure drop, pressure fluctuation, whether the cycle was okay but in between there was temperature went below the reset temperature or low temperature was there. Just check it out, these factors with reference to the cycle parameters. If it is initial qualification, then we may also want to look whether we need to modify certain parameters or not. If we are observing repeated failure, then we have to relook at the cycle parameters as well, whether we want to increase the number of vacuum pulses, number of steam pulses. Just we can look that way also for a specific load item. Third important factor is placement of biological indicator. We may have properly placed load, proper parameters, but if our BIs are not placed properly, if it is not clearly defined that how to place BIs. For example, we want to put the BIs in the worst case locations, but if placement is such that the placement itself is restricting the steam penetration. For example, in silicon tube, if we want to put BI, or in a small SS pipe with a small inner diameter, if you are forcing BI inside, or small needle maybe we are forcing the BI inside, then that placement itself may restrict the steam penetration. So what can be done in such case? In one of the tubing you put BI, and in the similar tubing you put biological thermocouple sensor, so that we can correlate or just put the BI with the thermocouple, or we may want to use certain accessories which are there, which can by which you cut the silicon tubing from the inner two half, put that assembly, put biological indicator inside and then connect the assembly. This way it actually represents the how exactly BI has to be placed, and it will eliminate the false failure because of steam penetration which is not done, not because of actual steam penetration issue, just because the BI itself is acting as a hindrance or blockage for the steam flow. If BI is placed in such a, for example, if rubber stopper, we are keeping the rubber stopper bag. Rubber stopper bag has one side is polythene or polypropylene, plastic will say, and one side is paper. So if you are putting your plastic side down, then it may accumulate water. It will not allow the water to fall down, will not allow water to drain. And if BI is exactly in that place, then because of placement of BI, improper placement of bag, rubber stopper bag, and improper placement of BI, it will accumulate condensate. It will not achieve sterilization, and we may observe BI failure. Other things, if we are keeping our load item such that it accumulates condensate and BI also placed in exactly same location, that BI may not achieve the sterilization, we may not achieve the 6-block reduction. So this is how it is important. The BI placement, same as the load arrangement, we have to exactly define how many number of BIs, which location, how to place the BI, also put the photos of each and every BI, not a general photo of entire chamber. Place the photo of each and every BI. If required, use the schematic diagram, but make it very clear that exactly how BI has to be placed. For example, if we are placing BI or sensor downwards, then condensate will go through the BI, go through the sensor. So we will have temperature drop in sensor also, and we will not get the BI killed properly. So the BI placements, the BI should be kept upwards. Sensor also has to be kept upwards. So because of the condensate, it will not get temperature fluctuation, and just because of condensate, it will not get the BI failure. So BI placement is very important. It should be thoroughly looked at. Exact location, exact description how to place it, and exact photographs really helps in achieving the proper sterilization and helps in preventing false failure. Fourth point is quality of BI. So for example, if you have raw BIs which are not proper, if there is any change in the lot, handling of BI is not properly handled before putting or after cycle. If there is change in BI vendors, BI lot number, BI quality, how we have stored the BI, like BI has a specific storage, biological indicator has a specific storage condition when it is stored and when it is not in, when before use. So if that storage is not proper, then it may also impact the quality of BI. Once we are taking the BI out of the autoclave, how it is handled, whether by incident the BI strip is open, it is exposed to the open air, open atmosphere, which may induce which may recontaminate the biological indicator, then also it can impact. So we also have to look at it BI quality, whether it is appropriate quality, appropriate vendor, approved vendor, whether what is the spore count claimed by the vendor, what is the D value, all this we have to factor out to rule out the BI quality. Fifth one is steam quality itself. So when this all investigation can be done stepwise or can be done in parallel, it is better to do the investigation for all the factored item like load arrangement, cycle parameters, BI placement, BI quality, steam quality in parallel, so we can complete the investigation on fast track and we can have a root cause as soon as possible. So coming to the steam quality, just also check the steam quality also, whether the dryness value, superheated value, saturated steam, non-condensable gases, all these values are meeting the criteria. So normally steam quality testing is being done every 6 months. Some companies also do the steam quality testing exactly before qualifying an autoclave, maybe during the initial qualification as well as during requalification. That steam quality test is being done just before the qualification to ensure that the steam quality is meeting the criteria and will not have any failure because of steam quality. Just check out the steam quality parameters. If we want, we can also check the parameters of the pure steam generator, whether there was any change, any fluctuation on that specific date which might have not produced the required quality of steam, which might have a lot of condensate, which might have a lot of non-condensable gases, which might have produced superheated steam. So these factors we can identify by checking the steam quality. We may also repeat the steam quality for the exact that specific steam supply for that specific location of autoclave chamber, and we can verify that whether any steam quality issues is there. We might have problem with the steam flow, maybe somewhere insulation is not there, somewhere there is a leak into the steam supply, maybe some leak into the at generation point, at distribution points, then also it can impact the steam. Also we have to check whether there is a clearly defined procedure to remove condensate before we start the cycle. For example, very first day of the cycle, we may want to remove the entire condensate which is there in line before we go for the actual cycle. One more factor, that whether which cycle is failing, first cycle of the day is failing, second cycle of the day is failing, third cycle of the day is failing, that is also plays very important role. For example, in very first cycle, if you have not removed the condensate from the line, then it may generate a lot of water at initial, and then it is very difficult for the rest of the cycle to remove that water and achieve effective steam penetration. This is also again indicated by when we check the cycle parameters. If it is not meeting, then also we can say there might be some issues with the steam quality or maybe high amount of steam condensate. So hope this steam quality also we can check it out and we can derive certain conclusions. We may not find the exact root cause, but we may find a lot of contributing factors basis that we can derive our CAPAs. It can be instruction for proper placement, instruction to check steam quality, instruction to check steam pressure, instruction, or maybe addition of photographs, training of the operators, and of course in your entire investigation you must involve the operators who are running the steam sterilizer as well as the supervisors who are placing the loads. That way it will be the ongoing training and awareness from them also, that what to investigate, how to investigate BI failure when in future such BI failures occur. We must wish that there should not be any failures, but if it occurs we must have to investigate also. So hope this small video will help you to understand and do a proper BI failure investigation in your autoclave. I will be preparing more such videos for the SIP system for lyophilizers. Be with me, be with my channel PHARMAVEN, and if you like, you can share my videos to your friends, your juniors, your colleagues, to your other groups also, to help me spread knowledge. Thank you very much for watching my full video.